there. Welcome to Astraveo's continuing education series, where for our podcast listeners, we talk about mathematics, the physical sciences, of course the natural world, and our personal favourites, astronomy. Now, you know Joseph and I are all up in and about astronomy. We get super excited about that stuff. So let's get going. For tonight's episode of Astraveo's education series, we're going to continue our exploration of the equation of a straight line. Now, if you remember a few days ago, we were able to work out the equation of a straight line. We're able to define it because it's an historical definition at this point, but we know it takes the form y equals mx plus c. Now, depending on which culture you grew up in, which country you live in, or which education system you're in, this might be written as y equals mx plus b. But where I grew up, which is mostly in Great Britain, we used this form, y equals mx plus c, and it's sort of burned into my brain. I don't really change that now. So if you're in the United States, where I currently live, the education systems here tend to use y equals mx plus b. But I'm going to have to stick with this, if you don't mind, because that's just my cultural heritage. Okay, so let's have a few formal definitions. X and y are just two coordinates in a Cartesian system. That means just a grid system. C, if you remember, is the y-intercept value. Intercept, don't forget the P. What that means is it's where the straight line crosses the y-axis. Formal definition. This M is the slope of the line, slope of the straight line. Let's be formal about this, the straight line. Okay, now we did discuss this already. But a very common question, in fact, on exams for school children, especially university students occasionally, but also just has a great use in science, mathematics, architecture, navigation, for instance, pilots use it, I'm sure, is if you have two data points on your grid in X and Y, what is the equation of your line? What's the vector of the line? So this is a very, very common problem for students. They are asked this question on standardized tests in their mathematics homework, and they'll use it as they develop their career in science. So typically what you'll be given is a pair of numbers, and I've got one here. I've already prepared one in advance. So minus 5, 3, and I'm going to use the other one, which is 0, minus 7. Are those two the right ones? Yes. Okay. Now, what the question will say is, given these two data points on a grid, and by a grid it means on a Cartesian grid, on an XY grid that looks like this, what is the equation of a straight line, or the straight line? Okay. Now, well, I remember doing this when I was young. I was 12 or 13, I think, when I first was introduced to this. I mean, I've always loved mathematics, but this is initially you think it is quite a complicated problem. It's not always easy for your brain to think, oh my God, it's y equals mx plus c. I don't even know the slope. I don't know the intercept. I can't imagine it in my head. Now, I always used to draw myself a little grid on the side of the piece of paper. Now, that's not too bad here. You can do that. These numbers are relatively small. But if this said 99, 24 and 153, minus 86, you can't easily draw a grid to represent those numbers. So I was able to do it for small numbers like these, but I wasn't able to do it for big numbers. Now, that is a graphical solution, and that's perfectly fine. That's a perfectly acceptable way to solve this problem. But its mathematical solution is actually not very difficult, and I'll show you how. So we can work out the equation of a line given these two data points. And if you remember, it's to do with the formal definition of a few things. First of all, this is a really special problem. And all you have to do is understand why it's special, and then you'll see that it's not so difficult. This data point is special. This is the second one, so we're going to call this x2, this one y2. This obviously is the first data point, and I'm sure you can guess where I'm going with this. Whoops. This is x1, this is y1. So x1 is minus 5, y1 is 3. X0 is x2, minus 7 is y2. But don't forget our definition of C, the y-intercept. It's where the line crosses the y-axis. Now, if you remember from your Cartesian coordinate graph, this is the x-axis, this is the y-axis. This line here, whoops, went right through my axis. This line here is the y-axis. Anywhere the line crosses this axis, that's your C, that's your y-intercept. But this line has a very special value. What's its value of x? That's right, it's 0. The origin here is 0, 0, xy. So this line, the y-axis, another way of writing it is the x equal to 0 line. Well, we so happen to have an x equal to 0 data point, which means if we were to draw this on a graph, I'm just going to do it very, very approximately, minus 7 in y, x is 0, which must mean the line, we don't know which slope it is yet, this way or this way, crosses the y-axis at minus 7. That's the y-intercept. That's the C value. So already, just from a very quick examination of the data points, we know that C is minus 7. So sometimes when you look at these problems, the answer's jumping out on the page to you. It's saying, hang on, look, don't think it's complicated. You don't have to go through lots of complicated equations. I'm going to give you one of the answers for free. If you ever see a data point that has an x value of 0, the y value is the y-intercept. Because we know this data point, I'm assuming this is y is minus 7, has to be there. It's approximate to I'm just sort of judging by the units, I'm just sort of guesstimating graphically. But we know that has to be the C value right there, because whichever line we're going to end up with, we'll figure out the slope in a second, it crosses the y-axis, the x equals 0 line, at y equals minus 7. We've just got one of our numbers for our equation. It's not too bad. Now, don't forget our definition from last week or whenever we last did the education series. M, the slope, has a very formal definition. It's y2 minus y1 divided by x2 minus x1. My trusty squeaky pen never fails. Some people call this the rise, some people call this the run. It's the rise divided by the run. Well, we have numbers for here. y2, y1, y2, y1, x2, x1, x2, x1. So this is all we have to do is plug the numbers into the equation and we'll have our slope. All right, because I'm running out of space, I'm going to put it over here. y2 minus y1 divided by x2 minus x1. And again, I'm going to put this here just because I like definitions. This is called the rise, this is called the run. All right, well, let's give ourselves a wee bit of space because, you know me, I'm all over this board and I write with big writing and I like drawing graphs. Okay, so M equals y2 is minus 7 minus y1, which is 3. Minus 7 minus 3. x2 is 0, we know that, minus x1. Now you've got to be careful here because x1 is minus 5. A minus times a minus is a plus, so we've got to be careful here, it might be tricked up. Minus 7 minus 3, minus 7, it's getting more negative, so it's minus 10. You have to be careful with that one, minus 10. 0 minus minus 5 is the same as 0 plus 5. These two minuses together give us a plus. So it actually is divided by plus 5. Well, minus divided by plus is a minus. 10 divided by 5 is 2. Our M is minus 2. It's a negative slope, which is nice, which means it must be this way, not this way. Okay, so we actually have our equation of a straight line. Let's just put this up here because I can do some erasing again. M is minus 2. We've got the two things we don't know about in the equation. Okay, so let's again erase some of this to give us some space. We know the equation of a straight line, we just defined it, y equals mx plus c. Whoops. M is minus 2 times x plus c, but c is already a negative, so it's minus 7. That is the answer. So if you're a student and you're in school or in university or college, and you were asked to find the equation of a straight line based on these two data points, this would be your final answer. You get the y-intercept here, the x equals 0 line, that's the y-axis, automatically gives you c is minus 7. The slope was very easy to calculate because we did y2 minus y1, x2 minus x1, y is overrun, and we were able to work out that the slope is minus 2. Very nice. Now that worked out really, really easily. We got c for free because we had one of the values that was x equals 0. What happens if you don't have x equals 0? Okay. All right, let's try one more problem, but this time let's make it a little bit more complicated because they're not always that nice. But at least now you know the method. And again, this is one of my favorite things, mostly because I originally, when I was young, I found this difficult. All right, so I did some research today, and we're going to have another example of this. I found there's some data points which aren't quite as simple. Minus 8, minus 9. Minus 8, comma 9. I mean, to be honest, I could put any numbers in there. We're going to get the right answer. So again, the equation, the question on your exam or your schoolwork or your university work could be, given two data points, what is the equation of the straight line? Don't forget, we already know the equation has to be of the form of y equals mx plus c. In the United States, y equals mx plus b. Okay, well, we don't know this time the y-intercept. This value, x value, is not 0. This x value is not 0, so we can't instantly work out c. It's a bit of a problem. What can we work out? That's right, we can work out the slope. We have 4 data points that are needed. 1, 2, 3, 4. Anytime 4 unknowns, 4 data points, we're in business. All right, let's do it. Well, I suppose M is normally my red pen is normally my solutions pen. Let's do this in purple or violet. So M, the slope, is y2 minus y1. Don't forget, x2, y2, x1, y1. So y2 is 9, y1 is 6, over x2 minus x1. Well, again, we've got one of these funky minus minuses. Okay, don't forget, minus times a minus is a plus. So 9 minus 6 is 3. Minus 8 plus 12 is positive 4. So our slope is 3/4. So that's interesting this time. It's not an integer. It's not a whole number. It's actually a fraction. Doesn't change anything at all. Not one thing. It's still easy to calculate the equation of a straight line. So let's put this off to the side, okay, because we need the space, obviously. Whoops, that was a really bad equal sign. 3 divided by 4, 3/4. So what would you do next? You don't know c. Well, you do know a couple of other things. Let's go back to our equation of a straight line. We need y and x and y. Well, we have some x and y's. We need m. We've just calculated m. So we know, we don't know. One equation, one unknown, we can solve it. That's a fundamental of science, by the way. Whenever you have unknowns, you need the same number of equations as unknowns to solve it. You have 2 unknowns, you need at least 2 equations. You have 10 unknowns, you need at least 10 equations. Well, we've only got 1 unknown, so we just need 1 equation, and we have it, and we have the data to populate it. Let's do it. So, y equals mx plus c. But we know m is 3/4. So y equals 3x divided by 4, there's the 3/4 for m, plus c. Now, these x's and y's are related. So I can use y2, x2, y2, or x1, y1. It'll give the same answer. I'm just going to, I don't know why, just for convention, I tend to use y2 and x2. I don't know why, I just do. So I'm going to plug these in. So for y, I'm going to use y2, which is 9. 3 divided by 4 times x2. I can't use the other x. I have to use the pair. You have to stay with the pairs. So y2 is 9. x2 is minus 8 plus c. Well, what I can do here is there's an 8 divided by a 4. This division goes all the way through this expression because it's a multiplication. So 4 into 8, 4 into 4 goes 1, 4 into 8 goes 2. So now we have 9 equals 3 times minus 2 plus c. Okay. As usual, I'm running out a little bit of space. Let's go back up here. I'll leave my y equals mx plus c. So now we have 9 equals 3 times minus 2 is minus 6 plus c. And what you can do is, depends on how you were taught this. We were taught when I was young that you would bring the minus 6 over the equal sign, it would become a plus 6. But I think the way they teach it these days is you add 6 to both sides. Those two cancel. Minus 6 plus 6 is 0. 9 plus 6 is 15. And there's just c, because this has gone to 0. C is 15. So now we have everything we need for our equation of a straight line. Okay, I've just written it up there so I don't forget. So y equals m 3/4. X plus c, c is indeed positive. There's your final answer. That is the equation of a straight line given these two data points. Yes, it was a bit tricky to begin with, but all we had to do was work out m. Yes, m turned out to be a fraction, but that didn't stop us. Once we worked out m, y2 minus y1, x2 minus x1, we have all those data points, 1, 2, 3, 4, so we can work out this equation. We were able to work out the slope. Once we knew the slope, we used one of the data pairs plus the m to plug in the numbers to this equation, and it gave us the c. We were able to work out the y-intercept. And then it's just a case of going back to your original equation. Y equals mx plus c. Y equals, this is m, 3/4, m. This is c, and these are the y equals mx plus c. That is how you work out the equation of a straight line given two data points. Thank you for watching.